Okay, that's great. It's 7:45 here. Welcome to Zurich. I'm very excited about this lecture today. It's on stocks and flows in architecture and urban design. And preparing it, one of our PhD students was laughing very much when I said, maybe this topic is only interesting for me. At least I'm very, very excited about it. And maybe during the lecture today, you get to learn a few new things. And it's fundamental for our research here in Singapore, and I think in the long run also for you. So that's the title of the lecture. Let's look at the content. First, the motivation, of course. Then I try to explain the concept of stocks and flows from different angles. And then I make the connection to stocks and flows in architecture and future cities. And then I do something very dangerous, and that is apply stocks and flows perspective to the flows and stocks of people, of water, of material, of energy, of density or space, of finances, of transportation, and of information. This is, of course, leading up to our lecture next week, which is on the simulation platform, but you need those foundations to understand what we are doing in the simulation platform. Then some conclusions. And then we have a very interesting contribution from a PhD student here in Singapore, from Chen Zong, who is actually working or has been working with stocks and flows of material flow analysis, and she focused on food. And then you can see one practical application of that. Okay, let's have a look at the motivation. The motivation, as we used it in our big Future Cities project here, we always showed this slide. And you have heard this, of course, many times, that by now more than half of the world's population lives in urbanized areas, where the definition of urbanized areas is not entirely clear, but the estimations are that by another 20 years from now, this number will increase to 5 billion out of a total of 8.1 billion. And you know today it's 7 billion people on this earth. That means many, many new cities are coming into existence that don't exist today. And somebody has to think about how to design them. Everybody knows by now that we cannot use the traditional ways of designing and redesigning cities, but we have to find new approaches. And this research that we're doing here is going in this direction. So these curves that you see there is the overall world population. But now, if we look at individual continents, the picture looks very, very different. I hope you can see this image. If you look at the top left, and I think you can see this time I really tried to make the presentation broad as your screen there. I hope you can see, and it fits the screen, because it was a lot of work to rearrange all these slides or to make them new to fit this strange format. Anyway, look at this at the top left. You can see in Europe, in the early years already, the population in the city and in the countryside was almost equal. You can read that at the left maybe. And then it started to drift apart, so that by today more than 400 million people are living in cities in Europe. So the is a very, very high degree of urbanization. Then if you look at Oceania, in the middle top, the population, of course, is much, much smaller. The scale, you can see the top is 40 million. But you see that there the urban population has been increasing steadily since the 1950s, and the rural population has stabled and is now declining slightly. Northern America, you can see the rural population has been decreasing since many years, and the urban population is the only one that increased, and that was the growth of the United States in the last years and decades is purely to be attributed to that. In Latin America, you can see that at the same time scale, the urban population was still less than the rural population at the beginning of the measurement, but by now you can see it has by far stretch the rural population. And then come two very interesting ones, and these are the ones that we are dealing with a lot here. Of course, this is Africa, and you can see in Africa the rural population is increasing, or was increasing, at the same scale and speed as the urban population, and only in a few years there will be where they meet, and then the urban population is growing faster than the rural population. And in Asia, as you see on the right scale, look at the numbers, the incredible numbers. The top number is 3.5 billion people. So that means by the end of this scale on the top right, you see that by then the urban population has by far outreached the rural population. And this picture, I think, shows you very clearly how differentiated we have to look at this urban-rural relation in these different continents. And it also shows something very, very important, namely a relation between stocks and flows. So what on earth is this concept of stocks and flows? It's an old concept. It's at least 50 years old or even older. But I give you a few definitions that are more recent and also a few older ones. So stocks and flows, as the name says, consists of something that's there, that's accumulated. These are the stocks. And then, of course, flows is something that flows in between the stocks, or flows into the stocks, or flows out of the stocks. And that's why it says very drastically, in terms of a metaphor, a stock can be thought of as a bathtub, and a flow can be thought of as a faucet and pipe assembly that fills or drains the stock, as shown in figure 1. This figure 1, if you go to the website, you can actually look at this, and it's animated. It's very funny. So the stock flow structure is the simplest dynamical system in the world. According to the principle of accumulation, dynamic behavior arises when something flows through the pipe and faucet assembly and collects or accumulates in the stock, which is the bathtub. In system dynamics, this is the field that deals with this, modeling both informational and non-informational entities can move through flows and accumulate in stocks. That is a very simple definition, and I think you can imagine what it means. Then, if you look to another definition, this is from Systems Dynamics. There it says one of the fundamental skills a system dynamics modeler, somebody who tries to abstract and model such a system dynamic system, must learn is how to identify the stocks and flows in the system, experiencing the problem that he or she is trying to model. This is a non-trivial task and one that people often find difficult. For example, it is not at all unusual for people not trained in system dynamics modeling. By the way, is any one of you trained in systems dynamics modeling? No, I didn't think so. Anyway, even those, they confuse stocks and flows. They'll say deficit, which is a flow, when they mean debt, which is a stock. Or they'll say that inflation, a flow into a stock, is lower, so therefore the general level of prices, a stock, is falling. So that is the example they give. And but they also make some interesting characteristics of stocks and flows. So stocks usually represent nouns, and flows usually represent verbs. So you can detect that in language. And the stocks do not disappear if time is stopped. That's important. So if you stop time, if you could do that, the stocks are still there. So that is a snapshot, as if a snapshot were taken of the system. But the flows do disappear if time is hypothetically stopped. So if you have a flow, which is a real flow, you stop time, the flow disappears. Stocks send out signals, information about the state of the system, into the rest of the system. And stocks have four characteristics. If you just look at the first two ones, they are important for us. They have memory, and they change the time shape of flows. I told you this was very theoretical. If you want to go deeper into this, have a look at these websites. They will be recorded on the podcast, of course, as always. And they have some very interesting and small examples so that you get a better imagination of what the stocks and flows, what they could do. Now, let's look at some of the architectural and future cities applications of stocks and flows. We have looked at the urban metabolism as one of our guiding principles for the future cities research here. So in this one, we understand the city as a dynamic system with negative effects on climate, negative effects, or I should say effects on climate. We try to read and model the system in terms of a modular composition. We try to recognize and react to system effects through integrated, intuitive decision tools, and we try to respect local identities and traditions in transitioning cities. Again, this is very abstract. How do you do that? Of course, you can do that in your head, out of your intuition, as it says, out of experience that you have from dealing with these things in other circumstances before. Or, and this is what we are trying to do in the simulation platform, you can try to have the support of information technology to achieve this goal a little bit better. And for that, we look at this urban metabolism. As you can see, it depicted on the left side with flows that go inside. So this would be the flows, the renewable flows coming into the system. Then in the center, you have the stock, basically, the human habitat. And on the right, you have the output, which is the flowing out of the stocks. And within these stocks, you can see there are these circular arrows. And this means that within the stock of the city, you have different cycles going on, trying to minimize the flow in and the flow out. We also deal with different scales looking at these cities. So you can see these scales at the top: building technology, the small scale, urban design, the medium scale, and territorial planning, the large scale. Remember those scales because they become important again towards the end. And then on the left side, for the first time, you see at the top left this word, stocks and flows, off. And then it comes energy, material, space, capital, people, space, water, people, energy, and information. You see those three groups there, basically grouped to small scale, architecture, building technology, and as an example, we use the Monte Rosa hut. Then you see the medium scale, urban design scale. As an example, we use the ETH Science City, where you are located right now. And as the large scale, we look at the territorial planning, and as the example, we take Ethiopia. Just remember this image. It comes again and again, but maybe with the explanation next you can understand a bit better. Let's look at some examples of stocks and flows. Some of them are related to city already. So this is one of the tables taken from Wikipedia, which is very low on information on this interesting topic, but it's growing quickly now. So you look at the stock, for example, would be the CO2 in the atmosphere. The possible units of the stock, how you measure them, is tons. And the inflow would be tons emitted, let's say from our cities, going into the atmosphere. And the outflow would be tons sequestered. You could do that either through CO2 sequestration in power plants, where you capture the CO2, pump it into the earth, or do other things with it, or by planting large forests and so on. And a possible unit of flow is then, for example, tons per day. So you see, stock are tons and flow tons per day. And this repeats in all the other examples again. Look at population, very important for our cities. Population measured, of course, in persons. The inflow would be births or immigration. The outflow would be deaths or emigration. And the possible units of flow would be persons per year. Then the water in the bathtub, I already mentioned that, but important also for cities again is the waste in a disposal site. And measured in tons again, then inflow would be dumping waste, and outflow would be the decay of the waste, and the possible unit of flow would be tons per week. So you can see many things that we take as given and don't think very much about either as a stock or as a flow, when they start to work together in a city, they become very, very interesting. And I think this is what I want to bring across, that you'll see those relations between stocks and flows in things that we take for granted in cities. Start thinking about this. Now comes the dangerous part, as I said. This has never been tested to this degree, and I hope you will disagree with me, and we should have a little discussion at the end of that before we move into Jen's presentation. So in this one I want to concentrate on stocks and flows of people, of water, of material, of energy, density, finances, transportation, and information, all related to our three scales that we have: the small, the medium, and the large. So let's start with stocks and flow of people. Famous people. Do you know all of them? Who's the man on the left? Anyone knows?
I know.
You have to, yes, you have to say, speak loudly, I can't hear you.
Our president.
Oh yes, he is our president, right. So he was giving the president, he was giving a big speech at the ETA talk just on Saturday. And then the man next to him, of course, is, do you know him?
Herzog.
Jacques Herzog, yes. And the man next to him?
Leuenberger?
Yes. And the man next to him?
No idea.
That's the Chinese Minister of Water. And the woman next to him is Flavia Schlegel. She's the directress of the Swiss Snakes in Shanghai. Anyway, these are pictures from the exhibition in Shanghai where the ETH represented or presented its Monte Rosa hut that you see in the background, and it's just an example for people. Now let's look, and these people not only are there as persons, as material persons, but of course in their heads they have an incredible amount of knowledge, which we also come back to later. Now let's look at this part here. So I think now you see the difference between stocks and flows of people. Of course, in order not to infringe on any copyrights, I had to look through all the database of pictures that had been taken. So there's no copyright on these pictures, and I can use them freely. So on the left, you have, I would say, a stock of people sitting there in a theater waiting for a performance to start. So this is relatively stable. You take a snapshot of this. You remember, a stock is like taking a snapshot, and the substance is still there, so the people are still there. Whereas on the right side, you can see people walking, obviously. So there's a flow of people across this very large bridge in Myanmar, and you can see the movement or the flow of these people by, if you're looking at their feet, because they wouldn't be standing like this for a long time, just on one foot. So I think you can see some difference between stock and flow of people. Just try to imagine this now in a building, in a small urban design area like Science City, or in a whole territory like Switzerland. Try to extrapolate and try to imagine what changes from scale to scale. And look at the next stocks and flow. This is obviously water. And this is very interesting water because it is doing all the things we were describing before. There's inflow, there's outflow, and there's a huge stock of water. And if you go further, then you can see, I think, the difference between the stock of water on the left, just a lake sitting there. It looks like it's doing nothing, but still it gets some inflow and some outflow. And on the right side is a very small and lazy river, but it is flowing water. So you have the typical stock and flow of water. Important for all our buildings, important here in the tropics, extremely important for every building, for every urban design scale, and of course more so for the territorial planning scale. Then look at the stock and flow of this. What could that be?
That's the Spanish audio in China.
Hey, great, yes. You're very specific, you know that immediately. I just want to get as a special property of this, which is material, stocks and flows of material. And here, I think you can imagine this quite well. On the left, you have the rock, the Matterhorn. This is really, I would say, a very good expression of a stock of material. Whereas on the right side, this is the example from Ethiopia, where people have managed to take the rocks apart and split them into little pieces by hand, waiting for the donkeys to carry up this then flow of material, of the previously rock material, up this ramp where it belongs in the building. So there, I think you can see, this comparison is a bit more difficult, but I think you get the idea. If you go to sand, to concrete, I think then it becomes much more, there's a real flow then of material. The next one would be the one of, any idea what that could be? Stocks and flow of
Energy.
Yeah, great. It must be. This is actually a warm water collector, as you can see, with the stock of hot water at the top. But of course, the flow of hot water is also going out whenever somebody is opening the tap in these buildings, right and left. And here we can go into a bit deeper definition. This is one of the old ones I found. When you have gone to Professor Leipengut's lecture, have heard a lot about exergy. And here, a very, this is 1989, so it's more than 20 years old, definition of exergy and energy. And you can see he looks at resources and then says there are stocks. And the stocks are split into deposits, for example, oil, minerals, metals, and so on. And a deposit can only produce a flow while its stock diminishes. So this is very important. This is like the non-renewable. These deposits, like oils, minerals, metals, they're non-renewable, at least not in a foreseeable time. And then what he calls funds are also stock, and these funds are forests, fields, and so on. And the yield of a fund is a flow. That means the forest crops and agriculture crops, and they would be renewable. And then he has the other one, the natural flows, the sunlight, the wind, the ocean, the currents, and so on. So that was in 1989. He tried to split it up in these two views, and that I found very, very interesting. If you look at it a bit more deeply, what he described there was actually the Japanese society, and this is something that hasn't changed since then. He refers to 1985, which is now a quarter of a century past. And then he said only about 21%, this is only a fifth of the material resources reached final use. Later, when Jen is reporting on the material flow of food, you will see that the numbers are also very low. So that means we have an incredible amount of losses, of waste from these material resources that we use until it is really reaching final use. And these heavy losses could be considerably reduced by an active resource budgeting and economizing at all levels in the society. Mind you, this is 25 years ago, and at this time already, and even before that, people kept saying that, people kept showing that. Maybe some people cared for a short time, but then they forgot again. And now this is very, very valuable again. So in the long run, exergy needs of a society must be supplied almost entirely from renewable resources. This was very much forward-looking, and he shows then the big figure 4. If you're interested, look up this report. It is listed at the bottom. Very interesting. Okay, back to architecture, what it means to us in Switzerland. If you look at the Swiss lakes, for example, this is you could say this lake is a stock of energy. It's a storage lake, and if you open the tap, you bring the water down to the Lake Zurich, it generates electricity, the stock is diminished, but it's replenishable, and therefore it's a bit more sustainable than if you would take it from other sources. And on the right side, you have the flow. It's hard to show the flow of energy in a building, but this is showing the flow of electrical energy in a building, in a typical building. However, this is Singapore. All right, let's speed up. I think you get the idea by now. Look at the stocks and flow of. Here I didn't find a very good picture. This is supposed to be space or density. If you look at this picture, which is of course Singapore, and it's the Marina Bay Sands at night when they open up the space of the city to the space of the sky above and make big light shows and laser shows, so they take much more space than the building occupies visually. Then you can imagine this is a high density, and we compare the stocks and flows of space to density. So if you look at these examples, high density buildings on the left, the flow of density, the flow of space is really hard to show, but here I just took a picture from the old Raffles Hotel. You can imagine space and time and people flowing through this actual space. But here you have to use your imagination. It's very difficult to pinpoint it and make a clear distinction between density, space, and stock and flow of space. Something challenging. We need that definition because this is essential for the definition of good urban design, of course. We're coming towards the end. So here I didn't find something better, but this is interesting. It's the stocks and flows of finances, if you want. These buildings you might have seen, actually they're almost completed now. They're by Libeskind. Of course, they are a big investment in the island of Singapore. Office buildings and residential buildings, a huge investment. So a flow of money into it. Then you have the stock of the building sitting there. Then this building starts to depreciate, lose its value more and more. So that would be the flow out. Here you can have, look it up also again on the web, on different sites. They have very nice models where they can show you have a stock A and a stock B, and the stock A diminishes, stock B is growing up, and the flow is the thing that connects both of them. And on the thing on the right, you have basically the same thing. You can see the flow of money from one stock to another stock. And on the middle picture, you can see if you have two different ones, how they flow. This is the top one is increasing, going down, and the bottom are the two stocks that you're looking at. Good. Finally, and that in Singapore, this is very clear. Stocks of finances. This is the new financial district. On the right side is the integrated resort or casino, where the flow of money is very, very big. But it's a difficult example. I think you get the idea, though. The next one should be easier. What could that be?
Traffic.
We have left transportation. So that would be stocks and flow of transportation and mobility. There's a picture from Ethiopia. And of course, you can also look at this transport and mobility of people. So this picture here, again, if you want to look it up, it's geographic mobility in the EU, and you can see every country is listed, and you see if this country is more internationally oriented in its mobility, and it's locally oriented in its mobility, and the ups and downs above this line are compared to the European average. So you can see countries like Sweden are very much mobile inside the country, not so much internationally mobile, and other countries are much more internationally mobile. So this is a mobility of people going in and out of a territory, and you have, would say, a stock of transportation media on the right side, and on the right hand you have a flow, hopefully a flow of transportation. The last example is stocks and flows of information. This is a huge supercomputer, of course, and knowledge, information and knowledge. And in a company, or in a government, or in a class like yours, there's a huge stock of knowledge already, and it's growing every day by what you learn. And of course, then there will be a flow of knowledge out into this class. And if you try to fix it on pictures, link on the left side is the stock of information, on the right side is the flow of information from the old TV and teleconferencing tower from which all the information was emitted. Conclusions. Small scale, architecture, stocks and flow. Why? Stocks and flows could be a better way to understand architecture. Its fixed parts, the stocks, and the dynamic parts and flows. What are we measuring? The examples for stock are the people that reside in it. These are just examples. Materials, energy embodied in the materials, capital that building represents. And how do we measure that? Differently. A stocks variable is one given at a given time, a flow over an interval of time, and you can imagine how you do that in a building. Buildings, easy. If you come to medium scale, urban design, more complicated. The urban design scale contains considerable stock, but the flow increases and differentiates as compared to building scale. What do we measure there? Stocks and flows to consider are people, space, and density, basically the ones that I showed before. And how do we do that? Movement statistics, 3D and 4D geometry, from geographic information systems, GIS, and so on. Then, interesting for the large scale, there we talk about cities and their hinterland. They form a vast system of stocks and flows. If we understand it better, we might be able to better design the system and to have desired impacts on local and global climate change, not only negative ones. Stocks and flows on the territorial scale are expanding below and above the surface. On the surface, we have food production and distribution on the surface, including water. This is what Chen will show you. But below, we have minerals and non-renewable energies, and above, we have airspace, climate, and weather. How do we measure this? We model it, simulate it, and weather and climate, we already know how to do that, but food cycle and impact on global and local changes need to be developed a lot. Finally, conclusion. Defining and understanding a concept such as the urban metabolism or models such as stocks and flows is important, even if and especially when priorities change or new discoveries are made. Thank you for listening to that. I want to give you now the last and very interesting example. Chen, may I ask you to come over here?
Okay.
Yeah?
Okay.
Are you still there? Still alive?
Yeah.
Okay. Yes.
And you drink.
What are you missing?
I have a question. The Wikipedia like people in time or something like
Yeah.
You're missing some. There was people in time. There's unit area. Length. If there was unit added per square meters, then people need to understand.
Yes. I think you're right. So people changes over time. This is, of course, here in this part of the world, one of the most important flows. You're absolutely right. And this is something that we have to add. We don't know how to model that because that is you can look at the numbers, they are clear. But the reasons for that, this is what we are after. This is what we really try to figure out. But you're right, this is an important variable. Now, let's have a look at the one example, the food material flow. This is Chen Song. She's a PhD student here. Some of you saw her maybe before in the recording of the conference from September. Here she is. Chen.
Well, hello. Nice to meet you again. I hope you still remember me because I showed up last time. And this time I'm going to give you a short report about information modeling and visualization of food material flow as an example. And as Professor Schmitt just introduced, there are so many different kinds of flows in urban space, like the wind, the energy, and and the finance and the transportation. And I choose a food as an example because food is something we can feel and we can even eat, like this cute bananas. And how much can food tell us? And how bad are bananas? Actually, food can tell us many things. When you eat food, actually you are producing some waste, and you are consuming energy. And what's more, when the food goes through the urban space, it will raise a lot of interactions between human behavior and the urban space. And at the same time, it will produce some carbon footprint. And here in my research, because I'm not an environmental engineer and I'm not an ecologist, but I'm a conservationist. I'm a computer engineer, so in my research, I'm trying to build urban information model from the material flow analysis, make use of this series. And my report will cut into two parts. The first part is a study on material flow analysis. And second part is more modeling, about modeling stuff. The modeling urban information with function and behaviors of material flow. Let's come to the first part. First is an introduction about what is material flow. As I show you here, you can see this is a human body. Every day we have to eat something to survive. And the energy goes in water, dry food, and on the other side is outflow. We have some carbon, water, phases, and our urban space is quite like a human body. Every day we have to input something and output something. Then we got urban development and urban metabolism. If you calculate what goes in, what goes out, and think about what happened inside, and then you got the material flow analysis, which is an analytical method of quantifying flows and stocks of materials in a well-designed system. And in this research, how to implement material flow analysis, we use life cycle assessment, which is a technical to assess the environmental impacts associated with all the stages of a product's life. And a deeper introduction, I will go quickly, is about this method. It can be used in different domains, as industry, marketing, and farming, and in different scale, building scale, city scale, and state scale, in different dimensions. This is a geo information, and of course, with quantitative elements to evaluate the mass balance. But this is not perfect method because it has some uncertainty and treatment and uncertainties like the parameters. People always choose different parameters to evaluate the balance, and they choose different scenarios, and because they are focused on different questions. And models, people use different models to measure the balance. So how to solve this problem? How to treat this uncertainty? A combination of LCA, life cycle assessment, and simulation is one of the solutions. So we try to use the simulation tool to solve those problems. Here, we try to introduce an interactive visualization tools to provide a dynamic view of the information of material flow. And this tool can help us organizing the data, understanding the process. And food is our first study case because food is so important. It's the basic human need. And before we get into the comparatively boring system design diagrams, I would like to show you some interesting images. This is our Singapore. The first one, the top left, is our food court in Singapore. As I show you here, there are so many people sitting there enjoy the Chinese food, Western food, what kinds of food there. And on the other side, it looks like a supermarket. Actually, it's a fake one. All the things here are waste. Just last winter, people began to collecting food waste from 150 families, and just after 2 weeks, they got this mini supermarket. Actually, all the stuffs there are food waste. And then I'm going to show you some 3 examples, some studies about food material flow. The first one is beef import from the other country into Singapore. I guess you already know that most of food in Singapore are import from the outside country. even if a small piece of beef have to travel really a long way from airport to airport, from one retail to another retail, is really a tough journey. And our question is that, is there a simple way to manage all those steps, this long trip? And the second study is a life cycle assessment for food product in Singapore. You can see that there are so many errors in these small pictures. Energy goes in and greenhouse gas goes out, and fertilizer goes in, food products goes out. And our question is that, is there a simple way to describe those dimensions, to describe those processes, comprehensive process? And then we go to the third study, third example. Is a review of the papers I read about this food topic. You can see there are so many suggestions for food efficiency covers from the farming end to the recycling part. And the question is there a simple way for us to build a model, to give a framework to cover all those topics? And then there's another summary. It's a summary of all uncertainty in this kind of research. People use different material, doing different process, and use different data sets, choose different methods, and measure different impact of the food material flow. And how to dealing with this? This is a question for our simulation work. So what kind of framework should we design for this kind of research? And then we come to our simulation part. First, we have to do information modeling, the structure and function. This is the structure of the material flow process. A material has a life cycle chain, and life cycle chain has several processes, and those processes contains materials, factors, and extension informations, something like geographics, what happened, location information about the activities. And then we came to the function and behavior. As I show you here, the left side is a diagram of flow chart. And you can see one material, it may compose by several kinds of materials. For each material, it has a life cycle chain. And for each life cycle chain, there are several processes. And for each process, we have input, output, and factors to measure it, and some environmental impact. If we calculate all the impact, we got the center pie. The center pie shows you all the environmental impact raised by this material flow chain. And after we got everything, we try to use some graph things to represent the information. And then we implement this conceptual model into a tools. And we use the food data in Singapore as a study case, as a testing data. Oh, sorry. Okay, it works. You can see here, all the Singapore food is imported from the other country, all around the world. And here we investigate 5 kinds of food, about beef, chicken, soya beans, and rice and tomatoes. As you can see here, there are several kinds of processes across the life cycle chain, from farming to manufacturing to transportation to retail, and to household to cooking and to cycling. And you can check the information for each process, the input, output, and the environmental impact. And you can go through, and you can see the little particles. The green one and the red one, it shows the mass transfer from one process to another process. And we can easily change the process to give a long retail chain. If we give a long retail chain, you can see that a lot of food waste during the long chain. And keep on adding more retail. And of course we can modify the certain process. As I show you here, I modified the cooking part. There are several factors or indicators can suffer some influence on the cooking step, and we can change some factors to improve the food efficiency. And then the first part is finished, but this is not the end because this is just a visualizing tool. It's not an urban information model. What we can do is far more than that. We can use this food material flow to link to the human activities. Because as I show you here, you can see we go shopping to buy some food stuff and cooking, and we're working to consuming this food material and we transportation to transfer this food material. We can also link this material flow to some ground features, as you can see here, the left is the processing in the food material chain, and all this process can be linked to a certain layer of the ground features. And we can also extend this food material into a general material flow to general activities. All the material flow as I show you here, is a behavior have all the dynamic process, and all the dynamic process can be represented by a series of events. All events has what, how, and where information. And we can also extend this material information to some urban information models, link to use some semantics to represent information and link to line with some standards like CTGML. And then with this, when we're dealing with the 3D models, 3D urban models, we not only see the geometric information, the function information, we can also see the environmental indicators, the environmental impacts raised by those buildings. And with this, we can mold the parametric urban information with some behaviors, functions, and structures. Thank you.
Thank you, Chen. Okay, thank you. That was an outlook already for the next lecture, which will be on the simulation platform. I hope we can take maybe one question, but reserve some question for next time. We want to start with discussing that at the beginning. I think the next time we also will do the course evaluation and show you what the information platform is meant to do and how this is related to architecture and urban planning. Is there one last question you want to pose? I realize we are a bit over time. So I thank you again for your attention, and I see you next week. I have to go to Australia tomorrow, but I should be back next Monday. Thank you very much, and goodbye.